Good day, everyone. We are tasked to discuss to all of you the attitudes of bed outcrops. So I'm Rima Sornido together with Mark Fernandez. What is the attitude of bed and geology? One of the key features to measure is the orientation of attitudes of bedding. We know that sedimentary beds are deposited in horizontal layers, so if the layers are no longer horizontal, then we can infer that they have been affected by tectonic forces and have become either titled or folded. So, attitude, a general term for the orientation of a line or plane. Attitudes refers to the three-dimensional planar and linear features such as a bed joints, a hornblende, needle, or a fold. The attitude of planar features such as beds or joints is defined by their strike and depth. So, strike it is direction of the line formed by the intersection of rock surface with the horizontal plane, generally expressed as an angle relative to the north. Depth, it is the angle at which a planar feature is inclined to the horizontal plane. It is measured in a vertical plane perpendicular to the features to the direction of depth can be true of as direction water would run down the plane. It is measured in a vertical plane, right angle to the strike of bedding. It is expressed in 45 degrees or in the 1 in 1 in gradient, 50% in percentage. So they have two types of depth, which is the apparent depth and true depth. Apparent depth is the inclination of geologic beds as seen from any vertical cross section, not perpendicular to the strike. True depth, the inclination of geologic beds as seen from any cross section perpendicular to the strike. So, attitude of linear structures. The attitude of linear structures is defined by Dutton and Planck together, but they define a vector. Trend is the bearing of the line, and Planck is the inclination of the line. Linear structures are also defined by the pitch rake on a given plane. Pitch rakes the acute angle between the line and the strike of plane on which the line lies. Example of linear structures: fold axis, hand line, intersection of two planes, slick inside, and other lineation. So the dip direction, it is direction along which a bed dips and perpendicular to the strike line. The dip direction is direction that drop of water will flow down the plane. So there are the depth and strike symbols in inclined bed, horizontal bed, and the vertical bed. Instrument used to measure strike and depth. So we have Broughton compass. It is used to directional degrees measurement, azimuth to magnetic field. So the parts of Broughton compass: first is a long level used for taking azimuth measurement of a strike. The second is circular level used for taking angle measurement of depth. The third is iron needle, points to magnetic north and it's dumped using the magnetic below the pivot point, but the bearing can be adjusted accordingly by rotating the declination pin. In the fourth 360 graduated circle, use azimuth readings that accurate to half of a degree, and the fifth 90-degree dip circle, used for measuring dip using long level to the vernier, and the sixth needle pin helps to lock the needle in place and other to take reading. In the seventh vernier, the vernier is used to inclination measurement with an accuracy 30 minutes. And the eighth, there are eight magnets, a cast of magnet which allows the iron needle to seek north accuracy and quickly. It has reduced the magnetic interference from any nearby environment. And so lastly, a declination of serpine, an arm behind the compass is used to move the pin using tabulated data on magnetic declination. The degree of correction is set. So outcrops. In the mountainous rocks and also shallow plains, exposure of rocks may be easily seen forming sides of valley or caps of hills, even uplands and slope and level fields. An outcrops is simply defined as the exposure of solid rocks on the surface of the earth. Any geological formation exposed on the surface, an outcrop is simply or rock column exposed of the surface, whether naturally because of erosion of the mountain or artificially. Because for the instance of road, cut, tunnel, or an excavation. So, outcrop dimension, the width or the breadth of outcrops per particular bed is given by the distance between the top-bottom edges of the bed as measured on the surface of the ground in a direction perpendicular to the strike of particular bed. Many variations are included in the breadth of outcrop of a rock by topography area. The thickness of particular layer of bed is the perpendicular distance between the top and the bottom surface of the same layer as seen in the vertical section as right angle to the strike layer. So the depth to particular layer or bed any place from surface is believed to present to the basis of general geology and depth of the formation. It's given by the perpendicular distance between the ground surface and top surface of the particular layer. So, stratigraphy, the study of rock strata deposited in earth, is preserved in the geological records. The immense mineral grains and fragments of rocks are produced by weathering of the earth's surface. They have removed the erosion exposed elsewhere as layers which are taken over time, and as the pressure increases, they have eventually compressed and lightened to form sedimentary rock. What is geological maps? A geological maps is a presentation about topographic map of the different types of rocks. The outcrops is a terrestrial area and the types of contacts among them. For distinguishing the rocks of colors are used in geological maps, the tectonic structures, faults and faults, fossils bed, fountains, minerals, resources, and etc. are also reflected. The geological map in is the presentation of the different types of rocks, the contacts, the image of the Earth's surface on topographic map. What are the geological maps? Geological map shows distribution of the rocks of the Earth's surface, rocks types, age of rocks, and also structures. So, geological symbols, strike and depth symbols provide information about three-dimensional orientation of geological surface such as bedding, joints, faults, and foliation. Using compass or clinometer, geologists measure the orientation of structures whenever they can find suitable solid rock exposure, as opposed to loose boulders. The orientation is angle are recorded as strike and dip respectively. Earth dip can strike symbols on a geological map usually represent the average of general measurement. Strike and dip are way of representing the three-dimensional orientation of lunar surface. A two-dimensional map, the depth is angle at which plane slopes downhill from the horizontal maximum slope, which is a right angle 90 from the strike. So here the geological symbols, map symbols, the under definition, explanation of symbols. The first definition, strike and depth beds, either horizontal or vertical. Strike longer line is horizontal line on bedding plane. Strike parallels nearby contacts between satisfied rocks. Dip shows how beds to run downhill. Dip angle number n of dip symbol is how beds tilt down to the horizontal. The second definition is horizontal beds. Because the bed is horizontal, it strikes all direction. Because the bed is horizontal, the depth is 0%. So the third is strike and depth on vertical beds. Strike longer line is horizontal line on bedding plane. Because the bed dips vertically has 90% depth, is equally either direction at right angles to strike to depth line is shown extending both direction. So, and the geological fault symbols, types of faults, map symbols, definition, types of regional stress, and geologic association. So first is normal, hanging down wall, footwall up. So tension, zone of crustal extension, divergent plate boundaries, age of horst and Grabens Basin and Range region. So detachment, low angle normal fault, foot wall, hanging wall, shallow crust, and tension. Boundaries are metamorphic coarse complex. Tra- Rise having wall up, foot wall down, compression, zone of crystal compression, convergent plate boundaries. So reverse, high angle 45-degree or more depth thrust fault compression, jo- zones of crystal compression, convergent plates boundaries. So strike depth, left rocks on either side move horizontally in opposite direction, share continental margins undergoing oblique not straight on, plate convergence, transform plate boundaries. So lastly is the oblique slip that combines horizontal and vertical motion combination, continental margins undergoing oblique not straight on plate convergence. So geological mapping tools are, which is they have aerial photographs that are taken from aircraft at fixed height above the ground, adjacent pairs of the aerial photographs with 60% overlap can be under a stereoscope to provide a three-dimensional image of landscape, which is useful for reconnaissance surveys. Geological maps it are uniquely suited to solving problems involving earth resource, hazards, and environment. Represent the distribution of different types of rocks and superficial deposit, as well as location of geologic structures such as faults and faults. Help us to understand not only where materials and structures are located, but also how and when these features form. So, magnetic compass, an instrument used to determine the direction of magnetic north pole. Clinometer are used to measure the angle of inclination of a surface, such as angle of depth of rock strata. The, there are three types of geological map, which is topographical maps, cross-section map, and also structural map. Topographical map is a map that gives information about the form of the Earth's surface, which is shaded or colored to show contour line or equal height, where different rocks units occur at or just below the ground surface. Cross-section map. A section line is a straight line drawn on the topographic map. Altitudes along this line are turned into a cross-section. A cross-sectional map shows the cross-section from the side. So the last D is the structural map. A structural map shows the geologic features of an area. So faults and joints. Structurally faults may be described as fractures along with relative displacement of the adjacent blocks has taken place. If just relative displacement does not take place on their side of fractures plan is called joints. Thus, both joints and faults are fractures is rock but difference is kind of displacement. Joints may be described as set of aligned parallel rocks of opening in geological formation. So a fault is a fracture across which two blocks has slipped. The displacement of adjacent blocks is parallel to the fault plane. Floating corresponds to the brittle failure of the underformed rocks formation or alternatively involves frictional sliding or pre-existing fault plane. Fault is a fracture crack joint along with there has been relative displacement or bends. So to continue our report, I will given to Mark Fernandez.